Welcome to my YouTube channel Physics Jagat. Small step to explore the gigantic world of physics. Friend, we saw in last video basic property of charges, that is charges are additive, charges are conserved. We are going to see third property of charges, that is quantization of charge. But before that I want to take one example that is given in your book. Very nice example. It is just like activity that we have done in the induction of charge. Okay. The question is that how can we charge a sphere, metallic sphere, positively without touching it? That is the question. Okay. So take one sphere like this, as we have taken it on insulating stand. So it is insulating stand, metallic sphere. As we know, metals are good conductor. So how can we positively charge this metallic sphere without touching it? Okay. So you know, how can we do it? It is by charging by induction. Okay. So if I want to charge it positive, so I must take it negatively charged body. Okay. So take a negatively charged plastic or glass. Okay, as I have taken here. So what happens? The free electron inside that metallic sphere will go in the opposite end, move to the opposite end, and this end will act as a positively charged. Okay, because we know deficiency of negatively charged is positively charged. So this end will be act as a positively charged, and these two will attract each other. Negatively charged plastic rod and positively end will attract each other. Up to certain time this will happen until the equilibrium established. Once the negatively charged electron experience the net force 0, that time only this process will happen. Once all the electrons in the body will established over here, what you are going to do, you just connect this end to the metallic conductor and earth it, ground it. So what will happen? These all electrons will flow through the wire going into the ground. So your sphere will what? Sphere will become positively charged only. And then after all the electrons will going into your earth, what we are going to do? Remove the conducting wire. And after some time we are also removing this plastic rod also. So if you remove that plastic rod, what will happen? Your charge, positively charged, will redistribute to the entire metallic sphere, and this plastic rod, this metallic sphere will be positive charged until you will not interact by some body. This will remain positively forever. Okay. So this is good example how you can charge metallic sphere positively without touching it. Okay. Now our next topic is quantization of charge. So friends, quantization, to explain what is quantization. Okay, quantize means what? Quantize means discrete. Quantize means discrete. Now if you will tell what is discrete, so discrete, to make you explain discrete, think about I will give you analogy. Discreteness is what? You might have seen the tap of water. Okay, you open the tap, the water will flow from the tap, and you hit slow. What will happen? Water will come from tap, but it will come out as a droplet. Okay, like that, not continuously, as a droplet. So this is a good example of discreteness. It will not continuous flow like that. Okay, so this is discreteness. It will come out as in a fixed amount, 1 drop, 2 drop, 3 drop, 4 drop, 5th drop. Okay, so this is discreteness. So we are going to explain just water droplet, just as water droplet, we are going to explain the quantization of charge, discreteness of charge. Okay, so quantization of charge. So charge on the body is given by, so one quantitative equation is there. Charge q on the body is given by, so this is charge q and E. This is what amount of charge any body possess. This is the equation for that. Q is equal to N into E. Now we are going to see what is Q. So we know what is Q. Q is the charge on a body, but what is N and what is E? N is the integer. N is the integer which can be positive or negative. It is not allowed to be N is N half, N is 1/2, 3/2, whatever. Okay, it will only be in integer form. Okay, so N. And what is E? E is the basic unit of charge. E is the basic unit of charge. Okay, now what is basic unit of charge? So basic unit of charge E. Now E is a charge electron and proton can have. Electron and proton can have. Now you might think, why electron and proton only? Why any other particle not? Okay, so E is the charge electron and proton can have. Now conventionally, charge of the electron is minus E, and charge of the proton is plus E. Here I write charge of the proton is plus E and charge of the electron is minus E. Okay, so this is convention. So as we have seen, this Q is equal to charge on a body, Q is equal to N E. So N is an integer. Okay, so the electric charge is always an integral multiple of E, is known as quantization of charge. Not any charge is allowed. Plus 1/2 E, 3/2 E. Okay, these are not allowed. Okay, not any value is allowed. That is discreteness. As I given you example of droplet. Okay, this is discreteness. So that's why charge is a quantized. Okay, so this is the quantization of charge, and this is very rough definition of quantization of charge. The electric charge is always an integral multiple of E, is known as quantization of charge. And there are many more example of quantization in physics. Okay, you might have heard the name of quantum mechanics. Quantum mechanics is entire quantum mechanics is stand on the quantization. Okay, actually origin of quantum mechanics is due to this quantization. Okay, that you will learn if you study physics further. Okay, now as we have seen in last slide, that why we taken electron and proton charge. Electron charge and proton charge is a basic unit. Okay, why not any other particle? Okay, since first let us take a electron. Why electron? You might have know that electron is a fundamental particle. Electron is a fundamental particle. Now what is fundamental particle means electron does not have any constituent particles. Okay, if you break the electron, you will not find anything. Actually we cannot break electron. Okay, so electron does not have a constituent particle. So that's why we can take electron as a basic unit of charge. But proton, what about proton? Proton is made up of 3 quarks. Proton is made up of 3 quarks. One proton is made up of 3 quarks. Now what is quarks? Some of you might have heard the name quarks, but there are six types of quarks: up quarks, down quarks, strange quarks, charm quarks, top quarks, and bottom quarks. Up quarks, down quarks, strange quarks, charm quarks, top quarks and bottom quarks. Okay, up is a positive charge. Okay, now what happened, we cannot take up quark or down quark as a fundamental basic unit of charge. Why? Because these three quarks inside the proton will always in a bound state. Now SI unit of charge, now unit of charge is coulomb, okay, and it is denoted as a C. Okay, now this SI unit of charge at coulomb is defined in terms of electric current. Now friends, still we haven't studied about electric current, but very rough idea about electric current is moving of charge. Okay, moving of charge inside the conductor, moving of electron inside the conductor, that is electron. Okay, from now onwards you can remember like that only. Moving of charge inside the conductor is electric current. Okay, so there is one very small or very easy definition given in your book, that is what is 1 coulomb. 1 coulomb charge, so it is a charge flowing in the conductor wire, it is charge flowing through a wire in 1 second if the current is 1 ampere. So definition of unit of SI unit of current is ampere. Okay, if it is a charge flowing through a wire in 1 second if the current is 1 ampere. Okay, so if you give 1 ampere of current to the wire, then charge in flowing through in 1 second is 1 coulomb charge. Okay, so E, the value of E is, that you must remember forever until you study physics. Value of E is 1.602192 10 to the power minus 19 coulomb, very small value, minus 19 coulomb, 10 to the power minus 19, it is a very small value. Okay, for example, for numerical you can take this much of value as 1.6. okay, first digit 1.6 into 10 to the power minus 19 coulomb. Okay, in numerical it will be very useful and helpful. So now we have a value of E 1.6 into 10 to the minus 19 coulomb. Okay, we have this formula Q is equal to N E. So we can find how much electrons there is inside in 1 coulomb charge. Okay, how much amount of electron there is inside in 1 coulomb charge. So let's calculate it. Okay, if you take Q is equal to 1 coulomb, N is that we want to find, this we know. Okay, N is equal to 1 divided by 1.6, this we will upside. Okay, 1 divided by 1.6, so 0.625 into 10 to the power 19, so 6 into 10 to the power 18, forget about 6, this much of electron in 1 coulomb of charge, 10 to the power 18 electron is there. This is a huge number. That means what? 1 coulomb is not a small number, it's extremely large number. Okay, it's not a small charge, extremely large charge. So in electrostatic, what we are going to do in our numerical problem, we will not take 1 coulomb, but smaller than 1 coulomb, that is micro coulomb. And micro, you know, micro is equal to 1 micro coulomb is 10 to the power minus 6 coulomb. Similarly, this is micro and this is milli. Similarly, so in numerical problem, in daily life problem, we will deal with micro and milli coulomb. Okay, we are not going to take this coulomb because it does have a 16 to 10 to the power 18 electron. It's a huge charge, so that's why we will not deal it. We are dealing with micro and milli coulomb. So if any charge body, or if any body, not charge, any body contains say n1 electron or n2 proton, so the charge of the body, now we can find how you can. So charge on the body, if it does have n1 amount of electron, n1 amount of electron. Now electron has a conventionally charge negative, and so total charge of the body, sorry, okay, and n2 amount of proton is positively charged. So what is the total charge of the body? So n1, sorry, n2, this is positive and this is negative, that is n2 minus n1 into E. Now this n1 and n2, we know that n1 and n2 are integer. It must have positive or negative value. It does not allow to have a half, 3/2, any value, okay. Its allowed value are positive or negative, that's why they are integer. If these two are integer, then its summation or subtraction will also give you integer, okay. So this bracket will also integer. That means what? Charge on any body, total charge on any body is always integer and in step size of E. Step size of E means what? It will give you 2E, 3E, 4E, whatever, NE, but not half E. This will not allowed, okay. So this is the total charge on any body. Step size of, it will always in a step size of E. E we know 1.6 into 10 to the power minus 19 coulomb. So friend, as we have seen, the total charge on the body is n2 minus n1 into E. That means in step size of E. But macroscopically means at macroscopic level, this step size of E, what does it matter? How does it matter? That we are going to see, okay. At macroscopic means at bigger level, okay, when body is considered at a larger level, okay. So we consider charges that are extremely large as compared to our basic charge, unit of charge, that is E. Charge of E, that we know 1.6 into 10 to the power minus 19 coulomb. And as we have seen in previous slide that we are going to deal with not 1 coulomb but microcoulomb or millicoulomb. So 1 microcoulomb is also big compared to the charge of this body, 1.6 into 10 to the power minus 19 coulomb. So 1 microcoulomb is, as we know, micro is 10 to the power minus 6. So approximately 1 microcoulomb is 10 to the power minus 6 coulomb. But how much electronic charge it is contained? So 10 to the power minus 6 coulomb, sorry, 1 microcoulomb is, as we say, 1 coulomb contain 10 to the power approximately 18 electrons, okay. So minus 6, so approximately 1 microcoulomb, 18 minus 6, approximately 10 to the power 18 electronic charge it does contain. Means 1 microcoulomb has that much of electrons, 10 to the power 13, which is still not a small number, it is also a huge number. That means 1 microcoulomb is also bigger number compared to E. Okay, so as I earlier told you that charge on the body is increased or decreased by in step size of E, which is very small. Now you consider macroscopically, we take microcoulomb. Microcoulomb is that much of charge. If I increase in 10 to the power 13, if I increase by 1 that much of unit or decrease by that much of unit in this much of charge, it doesn't make any difference. That means at macroscopically we must ignore this step size. Okay, that means we must ignore step size of E at macroscopic level. Okay, because if I may decrease from 10 to the power 13, 10 power minus 19, it doesn't make any difference. Okay, because it is a very small number as compared to this much. So we are ignoring this step size of E. That means as we have told that charge is quantized, but here what happens, we are ignoring this. That means charge is not quantized at macroscopically. It appear continuous. It appears as continuous. Okay. Microscopically means for smaller body, atomic level. Okay, at atomic level we are where charges are 10 or 100 order of 10 to 100 order, there of order of electron E, means there we consider 10E, 100E, 200E, that much at microscopically. Okay, not 10 to the power 19E of E. Okay, this is a huge, 10 to the power 13E. This is macroscopically. That's why 10 to the power compared to 10 to the power 13, E is very small. Here what happens, 10E, if I 10E plus 1E, that is 11E. Similarly 100E plus 1E, 101E, or 100 minus 1E, that is 99E. So here I cannot ignore this. Okay, here I cannot ignore the step size of E because it is very small number. That's why. Okay, so microscopically we cannot ignore the microscopic level. At microscopic level one cannot ignore quantization. Okay, so this is the basic difference of quantization. At macroscopically you can ignore quantization, but at microscopic level one cannot ignore quantization, but because quantization is there. Thanks for watching my channel. Bye bye, take care.